Okay, so here's more theory about delegates, and I'm finally starting to get more understanding and somewhat full understanding of how the delegates work. So, continuation of the learning is going to be learning what delegates are and how to create a custom delegates. And this part is just going to be the theory, then I'll do the code in the next video. So, what I'm going to be doing is I'm going to be learning how to create delegates and how to connect them with their event handler, and also learning how to raise the events and use event args from the code. So, good way for me, although the pipeline is a good idea that Dan Whalen uh, in the videos plural said that I'm learning from used an analogy of a pipeline, which is good, but I kind of understand it more when I think of the dump truck, to where delegate is a vehicle that just puts some data on it and it takes it to its location and it dumps it. So we have to have a vehicle to transfer this. So that vehicle is a delegate. So delegate simply knows how to pass data. All it does is just like a dump truck. It doesn't really do anything with this stuff that it carries. It just carries it from one point to the other. So anytime in .NET Framework when an event is involved, there's a delegate behind the scenes. Anytime you want to dynamically invoke different methods, then we have delegates. And delegates can stand on their own. So creating a custom delegate. Creating a custom delegate is what I'm going to be doing. And this is the example of how to create a custom delegate in code. So we use the delegate keyword, void, meaning this one is not going to be returning anything back. It's just a one-way, so the dump truck won't be coming back with anything. So one-way dump truck route, delegate keyword defines it, but the whole thing of defining it is a blueprint for the event handler method. So this is the key, is the parameters that we assign delegate keyword to. Now this is a dump truck. It becomes a dump truck by putting the delegate keyword to it. Otherwise it would look just like a method, right? Public void blah blah blah, you know, like abstract method without any body. But by putting delegate, now we're making it into the dump truck. Completely different thing than method. And behind the scenes how this works is that now when the compiler sees this delegate keyword, it generates a whole another type, obviously, that inherits from delegate base class. And the handler method must mimic the actual signature of the delegate itself. So the method of the dump truck, that's the way that they crafted this, it has to match exactly the signature of the method, event handler method. The name doesn't have to be the same. So what happens behind the scenes when we are creating delegates? We have a base class delegate which has some properties. Most important ones are method, target, and get invocation list. So it's a delegate is a base core class that provides functionality on how the custom delegates will work. So it has a method which is a property that defines the name of the method where the data is going to be dumped. Obviously we have to have the method name. And target, this is if this method is in a different class, so it has to instantiate that class. And that get invocation list is a way to hold multiple delegates and this works through this multicast delegate class that inherits from delegate, and it's an array of multiple delegates basically. And this is how the magic happens behind being able to send to more than one method. So the dump truck can go to more than one method. So our custom delegate indirectly inherits from these two classes. We can't inherit from them, they're completely sealed. So when we use the delegate keyword, compiler then understands that what we're trying to do, we're trying to generate a delegate. It will then create a custom type that will inherit from these two guys, and that's the delegate. And here's a little bit of a code examples of creating a delegate instance. So we hook up a delegate with a handler by newing up our delegate. So here's our delegate, and then we create an instance of it just like we would have any other object or any other class. So we new it up by using a new, and then we have to put a method name. So the actual delegate creating the vehicle, has to do with creating the blueprint for the method. Instantiating it, we actually had to pass the method name, and here's the method. To invoke the delegate, we simply call it like we would a method. So once we have all this, in order to call it, we just say delegate1 and send the parameters. And to invoke multiple delegates, which is using the multicast, we create a new instance and point to a different function. So we create now instance 1, instance 2, each one pointing to a different one. But to tie those two together, we use plus and equal. So now they're both added to invocation list within our crafted delegate type, that's been created by us using this delegate keyword. Now we're telling it we want to create doing two different things. We'll link them up. They're now added to this invocation list in memory, somewhere behind the scenes. And now when we do our call, even just using calling one, since they're linked, they're added to invocation list, this will actually send this data not only to work performed 1 method, but we can have another work performed 2 method that will do something else, but the data will be sent to it as well. So that's in theory how the delegates work. I will next do the code explanations of how the single and multicast delegates work.